Hi guys, I'm here from AzureFilm and I have the pleasure of speaking with the team behind the Astra project. And first of all, I kindly ask you to introduce yourself so we can get to know each other better.
I'm Antonio, the responsible of the Scout prototyping section, and the main objective of the project is to develop this spherical rover, which you can see here in the background. It is half a meter of diameter. When it's closed, it can open and extract an arm, a robotic arm, to take objects, samples from the lunar surface, accomplish those small missions, for example, taking some tools outside or even exploration missions. So this is its main objective. And another important fact about this rover is it aims to work with other rovers that we hope to develop in the future. So we will have like a fleet of rovers that will work together around this lunar base. That will be our ideal final project. So putting together all the parts, we will have this lunar base with solar panels, rovers that work on it.
Very interesting. I never heard of a project like this done by students in Europe. So where did the idea for this project come from?
The idea is to practice about all the team we study here at Politecnico. So the practical part, our main team, and we don't do a lot of practical work in school, so our university gives us the possibility to create a team, and so here we are to practice more and experiment.
That's really nice. So for how many years has been this project going on?
About 2 years.
Okay.
So this is the fourth semester. Yeah.
Okay.
We start October 2022. In December 2023, we present Scout, our first prototype. We develop and test in 1 year. And the goal is also to make a new project every year. So, for example, this year we are currently studying origami system of solar panel. So we can send to the moon a small object, and this object can deploy and have a larger surfaces where we can put a solar panel to power up Scout, our first rover, and also all the other components of the future base.
Basically, why you chose this origami structure is probably because it's easier to transport, or why did you choose this structure?
We have here an example. This is the tower folded, and after that we can unfold it and have a larger surface.
That's really nice.
The dimensions are going to be 2 meter and 2 meter, and it's all 3D printed also.
Okay, perfect that you mentioned 3D printing, because I just wanted to ask you for the Scout rover, how did 3D printing contribute to the development? What were the main processes or parts that 3D printing helped you create?
So 3D printing was fundamental for us to actually prototype the parts. We have a box of trials of parts because assembling together the sub-assemblies of the rover was very difficult, just only to design the parts, because the fitting of the parts was really unpredictable. So we tried to give tolerances in the CAD and so on, but we then discovered every time some new little details to adjust. So being able to print quite fast structural prints was quite important for us. We had a lot of tests, and to get to the final project, it was essential for us to try a lot of parts. Also, in the interaction between the printed and designed components with both components. So we bought, for example, some motors. We had to try and measure the right distances of the motor, and so try and print it, and it wasn't correct, and reprint it, and so on. And it was essential. Yeah.
Also, is the only technique we used to make a Scout rover. We don't have machine aluminum pieces, etc. Because our goal is to make a lunar base, and to do that, 3D printer is essential because we can send the material and we can print all type of object replacement for the rover, for fire, our solar system, and our future project. Also, we choose the FDM and not, for example, powder printing, because in the moon we have no gravity. We are constrained in the base and have all the powder of plastic flying around in the base are a big problem. So FDM produce a little waste. We can print almost all our parts, and it's very useful because it's also a clean technology to make some parts.
That's really awesome. So not only you are trying to create a lunar base, but you also would be the first people to do 3D printing on the moon. That's really exciting. Okay, so I want to know, you used our materials for the prototyping, but like now the finished Scout, what material is it made from? It's 100% 3D printed, or do you have some other materials?
For now, I have to mention this is not really the final version of the rover. I mean, the first version, but it's just for prototyping. We are building the second one with upgraded materials, so this is almost all made of PETG, and we prefer to switch to nylon, at least for the shells and some structural parts. For now, also all the inner structural components are 3D printed, except the linear guides on the
Linear rod, bearings, and screw all the fasteners.
and obviously electronics and so.
Yeah.
We also print the gears.
The final Scout rover will be made of what materials?
We are still working on deciding which we will use, but we think maybe nylon will be the perfect option because it's flexible enough to allow a little of deformation in the shell. So yeah, it will be probably this material. In the next version we will use also some machine parts, at least in the center part, in the release center.
Also, we are trying to make a multi-material print. So printing, for example, TPU with PETG that permit us to have some grips where we want with TPU, for example, or just use PETG to add the stiffness where we want in some TPU-made part. For example, we are adding some protection, some dust protection cover, and we are going to try to print it on TPU with PETG.
But have you tried already the multi-material printing?
We have already tried. Now we have received some new machine, and we are going to explore it more.
Okay, that's really interesting, and I think I would really like to know what are the results of this multi-material printing. Can you describe why did you decide to use this spherical architecture? How does this design contribute to the functionality? Like, what are its main pros?
So the main pro of the spherical architecture is that it can't really turn over or tip to the other side like another type of rover with wheels. So even in very steep terrain, maybe it will roll at the end of the hill, but it will always return to the upright position. Also for a little protection from the sides and for its adaptability to the lunar surface, so it won't really have any difficulties to move around this terrain.
Also, the spherical architecture using a pendulum, a physical pendulum, permit to have a structure that is always stable. So also if we lose power, etc., we can roll, yes, but we have always our pendulum, so always fall in the right side of the rover and we can start again. The main pros of this type of architecture. Also, we have a really less part in movement. So we have the shell, we have the motor, obviously, but we don't have like in, for example, 4-wheel drive system, 4 motor, 4 bearings. We have only 2 motor, 2 bearings, and 1 big wheel. They augment the reliability of the older rover.
The steering is done by the swinging of the pendulum, so it won't have problems in the synchronization of the two sides.
Have you done any testing to like simulate the moon's surface?
Not physically yet, because we don't have so many times. The project takes us 1 year. Also students, so take the time to study the project, make the CAD, print all the parts, mount it and test it here is already a lot of time consuming. But this year we are planning to make some tests in some terrain like the moon terrain, and also we had already made some tests at some event. We participate in the university and also some presentation. There is, for example, Biennale of Tecnologia is a big event organized here in Turin. We were in the main square of the city with our rover and some other team of university to show it up to everyone.
That's really nice. I can't wait to see how the test will go. And I must say that since it's practically the beginning of the project, I think you made a lot of work already. Yeah, I'm really excited to see how it goes on. Speaking about the projects, do you have any new projects already? You said that one project per year is your goal.
Yes, we are currently studying another project, the second one, this origami type of solar panel that improve the stackability of our solar panel and compact it for the launch. And this is the most critical part. After that, we are going to send it to the moon. So that's the idea. And we deploy that and we can improve a lot our square meter of solar panel to square meter of launched payload. This project mainly built to power Scout, and also some of these solar panels are going to power up our future project. But the idea is to have one big solar panel that can produce enough power to power up 4 or 5 of Scout to make it work together. Like I said before, this is the model. You have to imagine that these one are going to make 2 meter on 2 meter. So it's pretty big and we have a lot of modules. We have to print about 24 modules of 70 centimeter for 35 centimeter, and it's going to be the big project of this year.
I assume that you guys already knew 3D printing from before, or did you start learning when you started doing this project?
I started when I started with this project, but I bought a 3D printer after the first month, so I was already planning to buy one, and it perfectly fitted with the project. So I also started a little at home, but I don't have so much time there and the printer is not so good. So mainly here.
For my part, I started printing a lot of time ago, about 8 years ago. But the last year we have to print a lot because Scout it's all 3D printed, and so we progress a lot with our 3D printing skills.
Okay.
Also we have the printer more and more stable and reliable for this type of project.
What about the modeling, the design? Was that hard to learn? For the 3D modeling part, a lot of people learn to 3D print but never make something of their own.
For myself, I was already designing a lot at home, so I built the stuff since I was really little. But I actually started with SolidWorks in the university. I used other 3D CADs before, but not this intense. So I think I developed a lot of skill in SolidWorks here. About the designing parts, I think the situation became better and better with time, but I have to say I was already quite used to it, so it wasn't difficult to adapt. But a lot of people enter and grow their skills here in the team, and after 1 year, 2 years, they are quite good on designing parts. It really challenges the physical visualization in mind of the parts while designing it, so you have to really know how it will be in the reality, think about all the interactions between all side faces and so on.
Yeah, so for example, we have to communicate a lot with our electronic division, for example, to know where the cable are going to pass, where they need to put sensor and so on. And also for my part, I already come here and I used a little bit of SolidWorks, but surely after 1 year and a half, my ability with SolidWorks completely changed. I know a lot of things that without a team and without this project, I never going to know.
It really motivates to work on something when you know you have a lab to test immediately what you design. So yeah.
Also 3D printing help a lot with that because we design pieces and we can send it directly to the 3D printer, test it, see if it fits on the other part and iterate this process. Also we are a lot now in the team because we are 50 people, and yes, also other people can join us and help with the project. Is really amazing to work with in this type of ambient.
Thank you, perfect. It's really nice to hear that you have a place for students to learn practical things that are outside a study program. So that's really nice. Okay, so you showed me this solar panel piece. Do you have a name for it?
Yes, its name is Fire.
Yeah.
We are currently studying on it, so we don't have a lot of technical info, but we are hoping to present it in December or January.
I mean, your project is really, really interesting. So, do you think that it will turn into reality someday, this project? Do you think you will be able to actually build a base on the moon?
I think for now, our designs that we build here, I think more limited to just student fun, maybe.
Yeah.
But obviously some parts, some studies on it can have implementations, but not the whole project, maybe. Maybe some parts, some small studies on it. I was thinking about some gears. We are studying now on a particular type of gear, but in the whole view, not so much, maybe.
This lunar proof, if we can call like this.
Yeah.
We need a lot of time, a lot of money, because we need special material, special printer, a lot of people working on it. There is some certification we need to. So it's going to be hard, but for example, in FIRE, the solar system project, we are currently using some internal standard, so we can produce. The idea is to make it producible in a larger scale than one prototype to showing up. For example, we standardize also in the team the screw we use, the bearings, something like this, to make it upgradable in a more industrial shape of product.
That's awesome. I have one more question that popped up in my head. Do you think that this design of solar panels is also maybe better to use here on Earth? Or do you think that the solar panels we have now are like the best possible design?
This type of solar panel are useful on Earth in some particular position. Also, for example, in a mountain when you have a little house, you can fold it in the winter so you don't have a problem with the snow or something like this. Also, it's little, so if you have to transport it, you can make, for example, one turn of helicopter and don't need to make 20 or 30 to have the same quantity of power. So yes, it has these advantages also here on Earth, but it's not a large consumer-based technology, that's for sure.
Yeah, okay, understandable. Okay, I ran out of questions. Do you maybe have something else to share?
No, we are currently also, like I said, studying PAHT, CF. We are trying to print it as well as we can, and I think this type of material is very good because we have not the similar properties of aluminum, but we are for a technology that all people can print at home with $1,000 machine. It's really amazing what we can do with that type of material, and I hope we can try, and with year and year of development of 3D printing, I hope we are going to have a lot of technical material usable also for not only like what we see every day, so printing miniatures or something like this, but also really technical material using in really technical project.
For the new version of the Scout rover, we will actually have two rovers at the end. We are working a lot on the topology optimization, so the main structural parts will be made with this optimization, and so 3D printing is a really good option for testing the parts in the first place, and we will see how this new type of designing parts will work for us. It's the absolute first time we are using this. For now we always designed just geometry parts and then printed them. Now we will try this new technique.
Okay.
Also, 3D printing let us make some pieces that are impossible to make with other type of, for example, machining. Also, topology optimization give us some really complex form to make, and is quite difficult to make it, for example, with machining, or you need a big machine with a lot of accessories to can make this, and we can simply use a 3D printer and have a better result. Maybe not with the same strength, but we are not so far behind. Also for us, it's really nice. We test your filament a lot before asking you, because our provider here in Italy sent us some AzureFilm, so we printed like 35 kilos the last year of filaments, and yes.
I think we answered all the questions. Thank you for taking your time, presenting your project, and we'll continue to support you. And maybe when you test the Scout, when you have the time to test it, or maybe when you proceed with other projects, we would like to check in again to see how you're doing and to keep this story going on.
Bye.
Bye.